Let's think about how to compute the value of this limit. The first thing we can do is just try to plug in x equals 1 and see what happens. In the numerator, we get square root of 1 plus 3 minus 2, which reduces to 2 minus 2, or 0. In the denominator, we get 1 minus 1, which is also 0. This means that the limit is of type 0 over 0, which is an indeterminate form. As we've seen in other videos, this means that we need to do a little bit more algebra before we can compute the value of the limit. Because of the square root, the first thing we need to do is rationalize the numerator. This means that we need to multiply the numerator by its conjugate, which in this case is square root of x plus 3 plus 2. We also need to multiply the denominator by the same expression so that we're essentially just multiplying by 1. In the denominator, we want to keep these two terms separate, the x minus 1 and the square root of x plus 3 plus 2. In the numerator, we can make use of the symmetry between those two terms to determine that the numerator becomes x plus 3 minus 4. Let's take a closer look at this step. When we multiply an expression by its conjugate, we get some nice cancellation. To see this, let's distribute the terms. First, we multiply the two square root of x plus 3 terms. Next, we multiply the first square root of x plus 3 by the plus 2 in the second factor. Then, we multiply the negative 2 by the square root of x plus 3 in the second factor. And finally, we multiply the negative 2 and the positive 2 to obtain negative 4. The 2 square root of x plus 3 term and the negative 2 square root of x plus 3 term cancel, and the two square roots at the start combine to give us x plus 3. This is how we reach the expression x plus 3 minus 4 that we saw earlier. To see how those square roots combine, let's recall that square root of x plus 3 is the same as x plus 3 raised to the power 1/2. Using exponent rules, we see that when we multiply these two terms together, we add the exponents, giving us 1/2 plus 1/2, or 1. So in other words, this term is just x plus 3 to the 1, or x plus 3. So now we can return to the expression we had before. The numerator simplifies to x minus 1, and we see that we now have a common factor of x minus 1 in the numerator and the denominator. Cancelling this common factor leaves us with 1 over the square root of x plus 3 plus 2, which is now defined at 1. So we can now plug in x equals 1 to give us 1 over the square root of 4 plus 2, which reduces to 1/4, and that's the value of our limit.